All right. Welcome to Frank Teaches DevOps. I got this grounded a few days ago. Frank Teaches DevOps. All right. In today's series, um, I've started a series on Docker. All right. A series on Docker where I'm going to have episode by episode one, two, three, four, to episode N. All right. So I'm starting off with Docker. Okay. So quickly, let me put this in presentation mode. Where are you? Okay. All right. Slideshow. Okay. What is Docker? Now, let's look at what Docker is. We've been hearing Bruce's word. Docker. Okay. What really is Docker? So you're going to see this definition from Docker Hub itself. All right. Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. So that's it. So Docker enables you to create images and to deploy those images as applications. All right. Create images, deploy the images as applications. All right. So that's what Docker does. It also enables you to create containers. You shall come to the container. Let's get further. Containers allow a developer to package up an application with all of the parts it needs, such as libraries and other dependencies, and ship it all out as one package. All right, let me just show us a typical example of what this definition is all about. Okay, a typical example on this machine. Where's that my video? I hope you're doing your work. I hope you're doing your work. Okay. Now, a typical example of what Docker is. I just want to show us Docker in a glimpse. Docker in a glimpse. All right. So now, look at this. Look at this. I want to deploy an Apache, an Apache web server. I want to containerize an Apache web server. I want to Docker Rise and Apache web server. I just want to show us what Docker is in two sentences. All right. Now, I'm going to look for Docker image on Docker Hub. And the kind of Docker image I'm looking for is an Apache. So let's search for Apache. Docker search HTTPD. Let me look for that. Okay. We have HTTPD. This is an image name. This is the Apache HTTP server project. Don't worry about all these commands. We are coming when we start in details, when we start proper. All right, you will get to understand these commands. Okay. Now I have an image from Docker Hub with the name HTTPD. This is this. Okay, let me use HTTPD. All right. So I'll say Docker. Now I have an image already. So from the image, I want to run a container. All right. So Docker minus D minus P. Okay. Don't worry. Don't worry. All these flags will be explained in detail in our later chapters. All right. Now I want to expose a port 2020. All right. Assign it to the port in the container that will be running on the container. All right. Then the image name is what? HTTPD. Then the container name, I can say web serve. Web serve. Let's see this. Oh, I don't need this part. Sorry, Docker run, please. Docker run, please. Docker Docker run, web serve, Docker, Docker run. Thank you. Sorry for that. Docker run. All right. So now this is what it's doing. I don't have the image locally. What is it? Remove this pass. Great. All right. So I've just run a Docker container, and it's a web server container running on this port 2020. Let's check that. So if I say Docker PS, you can see I have a container already with the name. I'm supposed to use the name flag. I'm supposed to use the name flag. Okay, let me other. All right, let's go ahead. Now I have a container running with the name Relax Lalande. That's the name that Docker gave to me. It's not my own name. And then the image I used in running the container is HTTPD. Okay. And this container is running on port 2020. Now I'm going to grab the public IP to this instance. Now, here's it. This is this instance running. And here is the instance. Docker, come here. Docker. Then this is the IP running. So if I go on my browser and hit that IP, let's check. It's not going. This IP on port 2020 is not accessible, right? It's not going. All right. So I've deployed this now. However, there is this virtual machine is being deployed from the cloud. So um on my firewall, port 2020 is not open. So I may have to go and open port 2020 and security. I use the security group and I go and edit inbound rules. I'll come up here and I'll say add a rule. Add a rule. I'll give the port 2020. Okay. And save. Save. Now, if I go back to my container and if I reload, I should get my web server up and running. I should get my web server up and running. So this I've just demonstrated is Docker in a glimpse. It's Docker in a glimpse. Let's go ahead. Let's go ahead. So this is all about Docker. It's a tool designed to make it easier to create, deploy, and run applications by using what? Containers. Now, same way, if I kill this container, if I say Docker rm, the container ID, I want to stop it. I want to kill it. Okay, that should stop the container first. I want to stop it before okay, let me just stop it instead of removing it. Let me stop it. It has been stopped. Then if I come back to my web page, if I refresh, um, you see that the page is no longer available. I reload, it's no longer available. But if I start it again, I say Docker start with the container ID. That's the container ID. Start. Let me start it. Can you see now? It's up. It's up again. So that is Docker in the glimpse. All right. So let's move ahead. So that was Docker. And the next concept is container. Container. All right. Now, these are different definitions about what container. Now, Docker, from Docker perspective, they have defined container as a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing. So this is how Docker itself has defined what container. Then now let's look at what Google has to say about container. Google said containers are packages of software that contain all of the necessary elements to run in any environment. You see? Now, here comes a lame definition. Very lame. A container is something used for packaging other smaller things. This is just what I see as a container. All right. Now, let's look at um, a concept of container in the shipping industry. All right. This concept of container was derived from the shipping industry. Now let's just look something. Let's say container shipping. Let's say container shipping. Then we go to images. Come to images. Now the same concept. Look at this now. Look at this. You know fully well that that box is not empty. Even if it is empty, the purpose of that box is for packaging. It's to package things. It's to put things in it. So that was why it became container. If you put okay, let me give us another instance. Let me give us another instance. I'll duplicate this. Let's say container packaging. Container packaging. Right? Now look at this. Anything you put something in, box, you package something in it, it's a container. If all of this goes inside a box, it's a container. All right. So the container contains these cosmetics. Let's say these are cosmetics. And if I manage to put these cosmetics inside of this box, the box is now a container housing those cosmetics. Okay. All right. So that's the concept. That's the concept of container. The same thing is applicable to what Docker is applicable to Docker, where Google said containers are packages of software, different softwares, different packages of softwares that are contained, that contain all of the necessary elements to run in any environment, packaged as one entity. All right? Okay. So that's container for you. So let's move to the next concept. Container versus virtual machines. Now, this is the architecture of running a container, and this is the architecture of running a virtual machine. Now, I'm going to take my time and explain the difference between these two and which is much more proficient and scalable. All right. Now, on the container architecture, we start from the infrastructure. The infrastructure could be your base machine, all right? Your desktop, your laptop, all right? That is your infrastructure, okay? Now, on the infrastructure, you have a running operating system. You have a host operating system. Your host operating system could be Linux, it could be Windows, it could be Mac, all right? Now, on the host operating system, you now have a Docker runtime. A Docker runtime is running on the host operating system. Now, on this host operating system, with the help of Docker, you now start creating containers out of images. You create containers out of images. So this Docker is going to run images. All right. Let's assume now every container is a process in isolation. Every container is a process in isolation. Let me explain that. Let me use paint. Let me use paint to explain why I say container is a process in isolation. All right. Let's say, for instance, oh, sorry, this is not nice. Uh, Let me use this rectangle. This is your OS. All right. Text. Where are you? Text, 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 text. Okay. OS. OS means operating system. B, breeds. Okay. Now, I can't. Oh, sorry. Oh, sorry. OS, operating system. Okay, this is your operating system. So in the operating system, we have processes. We have processes. Let's say process A, process B, process C, process D. And now let's assume that one of these processes is SSH. All right. Let me text two. Let's say this is SSH. Are you with me? Okay. All right. So now this is SSH. So you have different processes running on your bare metal. Oh yeah. All right. On your host operating system. Now we now decided, instead of allowing these processes, SSH process, okay, instead of allowing these processes to be running on their own on the host operating system, we can do something. We can embed, we can embed these processes inside of a sandbox. Inside of a sandbox. All right. So in this context, this sandbox represents a container. Now, I now, in this process, in this explanation, you can now see that I am now running my SSH process inside of a container. So the SSH process is no longer running on the base operating system, on the host operating system. It's now running inside of a sandbox. And this sandbox is going to be given a namespace. This sandbox is going to be allocated a namespace and also a C group. A namespace is just for classification, all right? A namespace. Then we have a C group. The C group is responsible for allocating of resources, all right, to containers in Docker. Okay, so this is just the concept. This is called a concept. So in summary, a container is a process inside of a sandbox. Okay, and it can also be seen as a process in isolation. Isolation because this SSH process has been isolated from these other three processes. Okay, all right. Let's go ahead. So this is what I just tried to explain. So in this container A is now the sandbox. So in the container A, you have a process called app A, and the libraries needed to run that application. All right. Those are all inside of this. Those are seen as the processes running in the sandbox called container A. All right. Now, the same thing is applicable to virtual machine, but a virtual machine is kind of resource intensive. All right. Now, from the virtual machine perspective, we have from the infrastructure, which is your base machine, then it uses what we call hypervisor. So hypervisor is a kind of firmware, all right, that coordinates the flow of resources, that does resource assignment between virtual machines and the base machine. So hypervisor, it acts as a middleman between the virtual machines and the infrastructure. So hypervisor is also responsible for allocating resources. It allocates CPU, it allocates RAM, it allocates storage to running virtual machine instances. Now look at this now. Look at this. In this context now, each virtual machine has its own guest OS. They don't share the same operating system. They have different operating systems. All right. Now each VMB, VMA, VMC, they have their respective operating system. But now on the container, they are sharing the same host operating system. So in the pros and cons, between the pros and in talking about the pros and cons of container versus virtual machine, I can easily delete container B. I can easily delete container B and spin a new one. But in the aspect of virtual machine, I may not be able. It will be too resource tasking to delete virtual machine A because you have to consider what you have put into this virtual machine. All right. So that is the pros. That's where container is much more scalable, flexible than virtual machines. I think with this illustration, you can see that container is actually different, much more, and more scalable than virtual machines. I can test with container any day, anytime, but with virtual machine, you don't try it because you need resources. And if resources are now available, you can do it. But container, I don't need those resources. All I need is just Docker, and I am up and running. Okay. Next, the next item, we have Docker best practices. So on Docker best practices, we are looking at one service per container. All right. Build context should be small, and then avoid unnecessary packages and less layers. All right. Now there's a concept called layering in Docker. Now when we say layering in Docker, what we simply mean is you have a base image. Your base image runs on Ubuntu 15.04. Now, in your base image, you have processes in that base image. This could be SSH, this could be Apache, this could be NIFI, it could be any other process. This could be any other process. Now, all of these processes are running inside of this image. Now, what Docker is telling us that from this image, all right. Mind you, this image are these processes are in read-only format. Okay, that's why you see the padlock here. Now, what Docker is telling us that from this image, I can easily deploy or create a container. From this image, I can create new containers. From this same image, from one image, I can create multiple containers. That is what layering in Docker is all about. Okay. Now move on to Docker's architecture. All right. The next chapter is architecture. Docker architecture. This is the complete architecture of Docker. Now, in this architecture, we have the Docker daemon, which is the server itself. We have the REST API. We have the Docker CLI. All right. So now the Docker daemon is the service. It is service that runs when that gets activated when you install Docker. Now, look at this. Sudo systemctl stop docker.service. So this docker.service, if I should run this, I use systemd to control uh, the Docker daemon. All right. So with this now, if I try running Docker PS, it's still running. Why is it still running? Service, but it can still be activated by Docker sockets. Okay, let me do this. Let me do this. Right. So that is the daemon itself. All right. It's the daemon itself, but it said it can still be activated by Docker sockets. All right, so that's Docker, that's daemon. So when you get Docker installed, it comes with the daemon, which is the service that runs. Then in between the upper layer of the daemon, we have the Docker CLI. So the Docker CLI is this that I'm doing now. Docker PS. All right, Docker images. Okay, this is the Docker CLI. Now, the Docker CLI and the Docker daemon communicate via the REST API. Okay, so when the Docker daemon is started, a request is sent to the REST API, which the REST API takes the request and send that same request back to forward the request to the Docker CLI, saying that the daemon is up. So if you run any command, I will be able to. It's just like a communication channel. It's like a middle guy between Docker CLI and the Docker daemon. So the rest, that's what a REST API does. All right. It allows the flow of request back and forth between Docker CLI and the Docker daemon. So on the Docker CLI, this is where I can manage containers. This is where I can manage images. This is where I can manage data volumes. And as well, I can manage networking. So this is all about the architecture of Docker. All right. So next is what was it? Sorry. Okay, Docker containers. All right. So Docker container is a runtime of an image, or we would say you can say is an instance. Yeah, an instance is in runtime. An instance of an image is a container. They are temporary. All right, depending on how you manage them. The layers in a container is read write. All right, it's read right. Now come back to layers in Docker. Now the layers in an image is read only. The layers in an image is read only. These are the layers. I said this could be SSH service, this could be another service, this could be Apache service. So these layers are read only. But the layers in container are what read write. As we see here, read write layer. Okay. Then we can create as many containers as we want from one single image, as we see in the layering in Docker architecture. All right. So you can create more than one containers from one single image. From one single image. Okay. Now, like we have here, we can use the CLI to manage containers. We can use the CLI to manage volumes. Now let's go to volumes and see. Now, volumes in Docker allows you to persist data after a container dies. Now, when we say data persistency, it means to retain the data. I want to have those data. Even if the container is no longer in existence, I still want to have the information that were in the container, that was in the container. I want to have them in a separate directory. So that concept, you use volume to manage that concept. So in volume creation, we have normal volumes, we have bind volumes, we also have anonymous volumes. So this is just an intro of Docker. So when we get to that episode, we shall see what we can do with volumes. The same is applicable to networking. Networks in Docker are way useful to provide network connection between containers. All right. So if I want to communicate between containers, network by default, there are default when you spin a new container by default, you get a default network. So by default, all containers belongs to a network, a particular network, all right, which is probably the bridge network thereabout. But if you want to create your own network separately and assign containers to different networks, there and then some containers might not be able to communicate with other containers because they are now on a different network. Now, yes, the next one is Docker Compose. So with Docker Compose, we can build multiple images. So multi-container tool to ease administration. So Docker Compose enables us to build multiple images, to build multiple containers, to build multiple volumes, as well as multiple networks. So that's the work of Docker Compose. Then we move to the next one. Okay, we still have that. Yes, I think that's all for that. That is all. But the take home is we've seen how what Docker is, and we did a small demo to show us a glimpse of what Docker is all about. Then went further to look at definitions, different definitions from of container from Docker, Google Cloud, and then my own personal definition. Then we also went further to see the difference between container and virtual machines, and we went ahead to look at Docker best practices. We also saw layering in Docker. We also looked at Docker architecture, where we try to give instances between the Docker daemon and the Docker CLI. And the guy who stays between this client and the server is the REST API, who coordinates requests between the client and the server. All right. Then on the client, you can manage container, images, network, and data and volume. Sorry. Then what Docker container does, they are instance of an image. They are temporary. Their layers is read only. Their layers are read only. Sorry, their layers are read write, and you can create multiple containers from a single image. We also saw Docker volumes. We saw Docker network, and finally we saw Docker compose. So thank you very much. Thank you so much, and I will see you in the next episode. Thank you. Thank you. And thank you for supporting Frank Teaches DevOps. Thank you. Thank you. And have a nice day.